Kubernetes is container management system. It means that it will manage containers for you. Before, you had to run the containers using the Docker container tools, and you were deploying the containers yourself in any system that you want. But assume that you have several servers and you want to run a lot of containers. You have to go to each node and see if it has enough resources. Then you have to run the container yourself. But Kubernetes does that for us. It looks automatically to the nodes and see if there are enough resources to the nodes that is good for the container. Then you decide to send that container over that. This is basically what Kubernetes is doing. Kubernetes has a command line tool which is called kubectl, that you can do almost everything in the Kubernetes with this command line tool. And if you want to run the Kubernetes in your local computer, there is a very interesting tool which is called minikube. And here with a simple minikube start, you can run a small minikube cluster in your local computer for your development or for your testing. Then if I run kubectl get nodes, you'll see that this is actually a one node container, one node Kubernetes. Later you can also add more nodes virtually in your Kubernetes cluster in your local computer. So for example, you can say kubectl get pods. You see that I have one pod which is called server. I can say kubectl get pods server -o YAML. You will see the definition of this pod. And pod is actually the basic entity in Kubernetes. It can contain several containers. So there are several containers inside a pod, and the lifecycle are the same. For example, if you run a pod, it will run all those containers inside the pod, and if you delete a pod, it will delete all the containers inside the pod. And there are namespaces. So if I say kubectl, actually in Kubernetes we use K. Usually K is used, which is an alias for kubectl. For it is easier to use K command. So you say K get nodes, K get namespaces. So these are namespaces that I already have. If you don't mention the namespace, always it is default. Otherwise, you have to say K get pods dash namespace or -n kube system. So these are the pods inside the kube system, which are actually the basic components of the Kubernetes. And for example, you can say get services. These are the services inside the default namespace. And namespace is actually group of resources in Kubernetes. And if you, for example, in some companies, they create a big Kubernetes cluster, and then they create one namespace for each group or team or department, and then they allow them only deploy resources or services inside their own namespace. You can define if one namespace can access resources in another namespace or not. So there are different policies that you can define. Okay, so this is the pod, K get pods, and if you want to see the logs of the container inside the pod, you can say K logs server, and these are the logs of the container inside the server, which is an Nginx server. Or you can say K describe pod server, and you see that the name of this pod is server. It is in default namespace. It is in this node. it has labels. There are overlay network or private network inside the Kubernetes cluster, and pods has IP. So this is the IP address of this pod. These are the list of the containers inside the pod. For now, this pod has one container. This container is actually an Nginx container. And then you can see if the container has environment variable, you can see it here. And there are volumes that you can attach to a pod or containers. You can see them here. And then also events of that pod is visible here. You can see that successfully assigned default server to Minikube, pulling image Nginx, successfully pull the image Nginx, and then create container, start container. These are all events happen to this pod so far. So there are many things, or actually everything is possible with kubectl, but because it is a little bit difficult and you have to write a lot, there are tools that makes the life easier. One of the popular tools is Lens, but better than that is a simple tool that is open source and free, and it's much easier. And with the use of shortcut keys, you can do everything only by keyboard and don't need any mouse, and you can run it in terminal, in remote server. It's very easy and useful tool that is very popular as well. It calls k9s, k9s. So in k9s, you can do pretty much everything, and there are also shortcut keys that you can see at top. Then it's much easier and faster. For example, these are the pods. In default namespace, you see, and if I push 0, you will see that these are the pods in all namespaces. So this one is the pod in namespace default, and these are the pod in namespace kube system. One is kube system, 2 is default. If I push L on a pod, you will see the logs inside the container inside the pod. If I push enter into the pod, you will see the containers inside the pod, which is server container. And again, it will go to the log. If I push the D, you will see the description of the container. And if I say, for example, :ns, you will see all namespaces, and then you can say, okay, I want to go to kube system namespace. These are the pod in Kubernetes management system or control plane. You see, these are the pods that are actually managing the Kubernetes. This is the core DNS for DNS management. This is the etcd, which is a distributed key value database that contains all information inside the Kubernetes. This is the API server of the Kubernetes that receive the commands from kubectl commands and also all other API calls. Control Manager is a service in Kubernetes that manages the deployments, the scaling, and everything else that needs to be deployed. Proxy is actually the service in Kubernetes that allow you access the services from the outside the cluster. A scheduler is the service that actually decide based on the resources that the container requires, decide that this container should go to which node. And a storage provisioner is actually a service from Minikube to be able to allow you to allocate a resource inside the local storage for your container to have persistent volumes. So this is the default, this is a pod, and also you can say svc to services. I create the service in Kubernetes is actually a load balancer, and you can create several pods for one service and have a service object in front of those pods, and the service will balance the load to all those pods. And if you enter on the service, you will go to the pods that actually this service is connected to, and then another inter will go to the container, then another inter will go to the logs of that container. Now I delete this service with Control D. Also, I delete this pod with Control D, and I want to create them from scratch. So I split the page. So here when I run the commands, you will see what is happening in real time in the Kubernetes cluster. I say k run server image nginx. So by this command, I will create a pod which is called server with the nginx image, and you can see the logs of the container that is running. Then to be able to access this nginx service, I have to create a service. For creating the service, I use expose command. I expose the pod server with port 80, and then if I go to SVC, you will see that this service just created 5 seconds ago that is actually connecting to this pod. Then you say minikube service server, and you see we have our nginx running. So this is one pod. I created and now I delete it. If you see that if I delete the pod, it will not be created automatically again. But in reality, most of the time we never create pods. Actually, we create deployments, and the deployment will create the pod itself and manage it. Let's also delete the service that I created. So the deployment is actually the object in Kubernetes that you can decide to create certain number of pods, and then the deployment will manage them, and whatever happens to them, or crash, or somebody delete one of the pods, then the deployment will automatically replace it and create a new one. And with deployment, you can scale up and scale down the number of pods. And to create I go to the pods. I say k create deployment. Now I call it server using nginx with replicas 3. And you see that deployment created 3 pods for me, and all of them are nginx. For example, you can go to see these are 3 pods that deployment created, and if I go to the logs, you'll see the logs. If I go to the deployment view, you'll see that I have one deployment that it has 3 pods, and 3 of them are ready, and it was created 28 seconds ago. If I enter on the server, which is a deployment, it will go to the pods that it created by this deployment. Enter again, it will go to the nginx container inside the pod. Enter it again, it will go to the logs. And if I push D in the deployment, it will show me the description of this deployment, which is in the namespace default, and it says I scaled up the replica set to 3. I go to the pods, and I can, for example, scale it. I can say k-scale deployment server to 5. Then it will create 2 more pods for me. I can scale down. I can say, okay, scale it to 2. Then it will delete 3 of them. And if somebody manually delete one of the pods, for example, I delete this one, then the deployment will create a new one automatically, because in the deployment I ask the desired number of the replicas is 2, then it tries to keep the 2 pods for this service for me. For example, I can delete both of them, and then you will see that deployment will create 2 new ones. Now let's go back to 3, and now I want to have a service or a load balancer in front of these 3 pods to be able to access them. Then I say k expose deployment server port 80, and then you will see in SVC that we have a service. If I click on the server or this service, you will see that I have 3 pods that is managed by this service or is connected to this service. I can say minikube service server, and you will see this nginx, and each time that I refresh this page, it will goes actually to one of those pods randomly. It is load balancer in front of those 3 pods. So this is the Kubernetes service, which is a load balancer, actually, internal load balancer. And so this is called imperative way. It means that running, creating, managing, monitoring stuff using the either command line or a console like k9s, a dashboard like k9s. But what if we want to create by infrastructure as code or declaratively? There are YAML files that are actually manifest of the resources in Kubernetes that if we create them, then we can deploy them using kubectl in declarative way. And then we can use it in CI/CD pipeline to create our automation. So actually there are lots of commands and details, and probably it's difficult to memorize them. There are some features in kubectl or Kubernetes that helps you to remembering the stuff. For example, one of the interesting command is API resources, K or kubectl API resources. Here you will see all the resources in Kubernetes. For example, you see that this is a pod. There is an abbreviation. It is a short form of that resource, which is PO. The API version is version 1. It is namespaced, and the kind is pod. And the namespace means that you can have a pod in different namespaces. But there are some resources that it is not namespaced. It means that this resource does not belong to a specific namespace. It is actually cluster-wide. Then there is another one. Then you see that there is like a pod, which is another one of the resources in Kubernetes. And then you say, okay, kubectl explain pod. Then it will tell you that, okay, there is a pod. The YAML file for the pod has these fields. Should have API version, kind, metadata, spec, status. And you say a spec is an object, and I want to see what are the details of the object to be able to write the YAML file for the pod. Then you say, okay, I want to please explain pod.spec. Then you will see that a spec has a lot of items that you can define. Affinity, for example, DNS policy, host IPC, etc., etc. For example, you see when the host name is a string, for example, you see that, okay, you have to provide the value for the host name, then there is no deeper level. But if you see that there is a object, then you can say, okay, I want to know more about the details inside this object. For example, init containers, you can say then explain pod.spec.init containers. Then it explain more that inside the init containers there are several fields that you can use to define your init containers. This is another way to help you write your YAML files without memorizing them. And also another way is that all the resources and the information about the Kubernetes are in kubernetes.io website. And documentation, for example, you can see pod volume. Then there are several examples that you can just copy paste and it will work. But a better way is that you use dry run. For example, when you want to say, let me first, now if I want to delete these pods, you will see that it will create the pod automatically again. The way that we have to delete this is delete the deployment, because those pods are managed by deployment. And if we delete the deployment, you will see that there is no pod anymore, and as we see, you can delete the service also here. Now if I say kubectl deploy create deployment, I can add dry run client -o YAML, and instead of creating inside the Kubernetes cluster, it will show you the YAML file that will be deployed to the Kubernetes cluster if you run this command. And then I can say, okay, now write it to deployment.yaml. Now if I see the content of the deploy.yaml is actually the definition of this deployment. In deployment, you say it is API version, the kind is deployment, and the number of replicas is 3. And this is actually the configuration of the container itself. The image is Nginx, and there is only one container. And then to be able to deploy this, I will go to first to the pods. You can say k-apply-f deployment. Then you see that the deployment will be created, and also the deployment will create 3 pods. Now if I want to change anything in my Kubernetes cluster, it is only needed to change this YAML file. Then I say, okay, I want 5. Now I changed the replicas in the deploy.yaml file, and to be able to deploy it again, I run the k-apply-f deploy command, and you will see that the number of pods will increase to 5. Now we can embed this command into our CI/CD pipeline, and whenever we change the code and then we push to the master, automatically the pipeline will apply the recent changes to the Kubernetes cluster. And it doesn't matter if you apply it several times, it always keeps the code and the reality the same. Now let's create a service for this deployment. I will say create expose deployment service port 80, and now I say try run equal client dash o YAML. So this is the service that will create. So the kind is service, and the port is 80, and the selector is app server. Actually, the selector is the mechanism that this service will actually connect to those pods or that container. And now I say, okay, write this service definition to the svc.yaml file. I can see what is the content of this, and then I say k apply dash f svc.yaml, and you will see there is a service now that if I connect to the service, it will go to these 5 pods. Now we can see if our service is working actually. But minikube service server. Yes, it is working. And if I, let me see, delete this service, you will see that this one will not work anymore, or there is no service anymore. Okay, so now I have 2 YAML files, one for deployment and one for service, and I can run this command to delete all of them. For example, if I go to pods, if I say k delete dash f dot, so it will go to the Kubernetes cluster and delete all the resources that are defined in all the files in current folder. It was deployment and services, and says, okay, deployment is deleted, services was not exist actually. So I can create all of them again. K apply dash f dot. It will create the deployment and the service. Deployment created, service created. So assume that there are hundreds of YAML files in one folder defining different kind of services, deployment, all resources in Kubernetes, and then by apply dash f dot, you will deploy all of them once to the Kubernetes. And k apply or k delete dash f dot, you will delete all of them with just one command.